Philips is already taking the lead in building the factory of the future. A 3D shaver pilot in the Netherlands lets consumers customize their very own 3D printed personalized electric shaver. We've also built a novel robotic tool to develop a radically new facial styling product that did not exist in either the shaving or grooming world. The tool uses active alignment and high-precision laser welding to produce a product every 1.5 seconds. That's 300,000 products a week, 24/7.
It's always nice for me to see, and therefore I'm proud where I basically work. Industry 4.0 is basically is thinking about the future, and we within PINS basically think about improving the operations over the entire product life cycle. And when you think about Industry 4.0, it actually starts at the beginning. It starts at product development. You have to do smart design with sensors, with design features which are there specifically for the assembly. You have to make a connection between the design, manufacturing and assembly. And at the industrialization, it's very important that you have a smooth introduction of a product. How to secure a new product introduction and to make sure that you do the ramp up in a right way. Test and optimize, use data to constantly improve. And after the first market introduction, there we have the word operational excellence, which you constantly hear. Operational excellence is about improving the quality and constantly also to reduce the costs. Together with the underlying processes of quality and reliability, as well as financial engineering in order to keep the revenue at the good level.
Thanks, Joost. Let's now have a look at some market trends that we find in industry and which are relevant for your manufacturing supply chain. First of all is the fact that products are becoming more digital. Software is more important, sensors are being built in. Example is an MRI system where you will see that future product generations will not differ that much in mechanical design anymore, in hardware design, but it's much more in the software where you will find the changes. The second trend what you see is diversification strategies, where you see increased product variability. And because of that, you will see a reduced lot size, reduced batch size of your products. It's more personalized, it's more customized. And the third trend you see is that supply chains itself are changing. They're becoming shorter, leaner, because from a traditional point, you have a distribution center to a retailer, to the customer. But nowadays, it's more e-commerce. It goes faster via Amazon and eBay. And of course, these kind of trends impact largely on the supply chain that you need. Let's have a look at one example I brought with me. I have here two lamps, traditional light bulb and an LED retrofit lamp. This one exists for 125 years. And we have been producing it for billions a year because it fails after 1,000 hours. After 1 year, it breaks. But over those 125 years, it never got any more expensive. So can you imagine 125 years of inflation fully offset because we use very efficient, very dedicated, fast production systems to produce it. The LED lamp lasts for 30 years. You put it in your socket at home, you never have to replace it again. That means after 5 years approximately, there's no more demand for such LED light bulbs. So your manufacturing supply chain for this digital product looks totally different. And that's depicted here in this graph, schematically. Depending on the length of your product life cycle and the volume, the demand that is asked, for the light bulb you can invest in a lot of capex. But if you move to here, the amount of money you can invest is much less. And you need to go to more flexible supply chains and supply chains, production systems, where you have much better reuse of capex. The most extreme case, of course, this 3D printed shaver that we saw in the video. The volume is one. It's unique, basically. And you need totally new technologies for that to produce it. And the answer, of course, is Industry 4.0. But what we will advocate in this presentation today is that it's not only about the hardcore technology. It's not only about the production system itself. Actually, you need to master three aspects. Of course, the production system is important, but it's also about the product design that needs to be suitable for Industry 4.0, and your organization and the people in your organization must be ready for it. Let's first have a look at the production system design. Rome was not built in a day, and you don't move into an Industry 4.0 factory overnight. You need to work on it, you need to plan it. It will take years to get from the current state into the future state. And what we do within Philips, we create a technology roadmap for that. So in all the aspects which are relevant in our factories, like the data you have, the planning, the manufacturing itself, logistics, analytics, etc., we make a plan how we move stepwise from the current situation to the final state of the smart factory. And for that we create pilot projects. An example is traceability of process data. You've seen the example of 3D printing. Flexible production, robotics, is a very important topic. And in order to make such a technology roadmap, we have adopted as Philips Innovation Services a toolbox from the German Machine Association, VDMA, which works very well to identify the steps you should take and can take in product design and in your production system design to get to Industry 4.0 in a successful way. Now, if you look to a flexible production system, and I want to talk a bit more in detail about that because robotics is a hot topic, then it's important to look at two aspects: flexibility in your production system and cost. Now, in the traditional way, when you do high volume production, like with the lamp, you can make dedicated production systems that produce at a high speed, efficient way, but only when it's about high volume. And of course, those systems are not flexible. If you need flexibility, you need to do manual assembly, and often you do that in a low-wage country environment. Now, if because of the market trends, you need to be closer to your market, to your consumers, or you see more personalization of your products and the batch sizes decrease, then dedicated machines become too expensive, and of course, manual assembly in a high-wage environment also is too expensive, although it's flexible. Again, solution comes from Industry 4.0, and within Philips we said, okay, we need to develop platforms that can make sure that this production moves via Industry 4.0 technology, in this case robotics, to a flexible and cost-efficient production system. And also for high volumes, we need to look at a suitable platform that we can use. And I want to illustrate that with two examples.
Philips Innovation Services develops platforms for Industry 4.0 based on smart robotization. At this moment, we are working on a solution on how to match human capabilities and performance. Our smart robotization solution consists of three key human capabilities to match performance. First, we create the human brain, the controller. Like our brain, it is adaptive, fast, highly flexible and intelligent. Secondly, we simulate the human eyes by developing a vision system that is adaptive to color and light, works fast and is free to move. Furthermore, the vision system positions each product so they can lay in arbitrary positions in the tray. Exact product position is communicated to the robot for grasping. Thirdly, we create the human hands. The gripper that we developed for that is universal and flexible with tactile sensors. It is able to really feel the task and can work collaboratively in a safe way. Key features of the gripper. 1. Integrated standard vacuum pump and piping, ejector. 2. Hard printed material for mechanical strength and positioning. 3. Soft and flexible printed material for sensitive surfaces, easy exchangeable. 4. 3D printed, fully customized. Like human hands, the gripper is fast and easily exchangeable for product change. It illustrates that smart robots are becoming more like human beings. The prices for these features are decreasing over time. Therefore, robotized production becomes more affordable, more flexible to different product types, and with high reuse of capital, as the systems are reprogrammable. It is our aim to deliver an easy-to-program, easy-to-reuse, reliable and safe robotized platform to accelerate your innovation.
So this is an example how we use the newest technologies as it comes to vision, 3D printing, robotics, in order to create a system that can work together with operators or even replace operators when needed. The other example I want to show is on a system that can produce at a high speed, but in a very flexible way. So basically you can produce on one platform different products and even in different speeds.
We have also taken key steps in creating a flexible assembly platform for products that are produced in high volume. In the platform, product carriers can be moved individually. Flexible part feeders are used to create a one-piece manufacturing flow on an automated line. The platform can easily be scaled from one product type to another, from lower to higher speeds and higher volumes.
So these are examples of 2 pilots we are running in order to build platforms for Philips in the production systems. As I mentioned, product design and the people organization are the other 2 pillars which are critical to be successful, and Joost will continue on that.
So the first pillar we've had, the production system design, and the next pillar is product design. In product design, it's always important to understand what's new. And what's new, then you have extra risks. And the other aspect, which is also very important, also for Industry 4.0, is the combination between product design, manufacturing, and prepare for automated assembly. Actually, what we as consultants always like to do is to make complex processes easier. Therefore, we like to use this V model. And V model is consists of different building blocks which are actually easily connected to each other. It starts over here. It starts with the customer requirements or business requirements, and then actually it goes all to the parts requirements. And what you see here in the shadow V, actually, that's the combination together with manufacturing, in order that it's designed in such a way that it can be manufactured, that it's designed in such a way, for instance, as I said earlier, that some features have to be built in which are not there for the product use, but which are there for the assembly. And other things, what is there, they often say first time right. Actually, first time right does not exist. It is about testing and optimizing and make sure that these processes are well structured in order that each test will optimize the next step. And when you go to this side of the picture, you see here again, that's the V, and you see here again from the parts realization and the parts verification all the way up to the product validation. And when you go one step deeper, you go to the DMAA. We like to use, of course, a lot of abbreviations, but DMAA stands for Design for Manufacturing and Assembly. We have a set of 20 guidelines within Philips, and they are quite useful. Also, when you look at Industry 4.0, O, I like to clarify two. First one is to reduce the part count. To reduce the part count, what it says, it simplifies the supply chain, but an important aspect is that, of course, when you have less parts, you can standardize the architecture, but also you can reuse. And reuse means improve quality and limit costs. The other aspect is to emphasize on top-down assembly. We as a human, we can do this and this and this, but the robot, it's difficult. It needs to be a stackable design in order to, to integrate. One specific question here is, you see here this monkey. It's and actually the question to you. What do you think? The monkey has two different arms. It can move its head, it can move its legs individually. How many steps are actually needed to produce this monkey, you think? 5? 7? 10? Basically it's 1. And this is about smart product design, using different plastics in such a way that it can be made in one step. So let's look at the third and not to forget important pillar. It's about people. We got one quote from the internet, and I like to read it out with you. We are currently preparing students for jobs that do not yet exist, using technologies that haven't been invented in order to solve problems. We don't even know our problems yet. And that's an important aspect. What does it mean? What does it mean for us? What does it mean for our business? It means that we have to invest in people. We have to make time for that. And basically, we've put 3 aspects over there. The first is about knowledge, competences. There is an increasing competence need going from hardware to software. Hardware is sometimes, engineers, it's easier, it's more visible. Software is less visible. That's sometimes also difficult. And also what you could see in the movies, you could see that we are building robots which have to look like people, but the robots and the people need to be able to work together better. These days, robots are often separate, but in the near future, more and more cooperation is needed. Also, think about change management, then, of course. Sometimes it can be a threat as well. And the last aspect is actually the management. We have increasingly data, we have increasingly a lot of information, and we should process it to information with which we can make the right decisions and translate data to intelligence and to prepare the changing value chains. So to summarize.
Yes, thanks Joost. Indeed, we started off explaining the market trends that we see, products becoming more digital, supply chains becoming more lean, shorter lead times, and because of that we need different production systems that are more flexible, production systems that make a better reuse of capital investments, etc. And of course their Industry 4.0 brings the solutions that we need to have. But what we advocated today is, in order to implement it successfully, you should not only look at the hardcore technology of the production system itself, but also relate that to a product design which is optimized to produce, for instance, with robots, and also to look at the people in your organization to prepare them for the technology switch which is about to come and which goes at an enormous rapid pace, moving from hardware to software, and also that they accept the calibration of work between human beings and robots. So we have shown how we do this transition within Philips and how we support that as Philips Innovation Services for Philips customers, but we also do that for external customers. So if you're interested, you can also always reach out to Joost or myself for further information. Thank you very much.